welcome to lecture 8, and we were discussing about mesh analysis, and recall that in the mesh analysis rule was like this: identify the nodes, choose a reference node. This I have chosen as a reference node, and then V A 0, V B 0, V C 0 are to be found out. Coefficient of V A 0 will be sum of reciprocal of all the resistances. Coefficient of V B 0 will be negative of reciprocal of the resistance lying between A and B nodes, and so on, and right hand side will be sources. So this is how one can really write it down. And then I took a situation like this, and I decided to solve it by nodal method. Then once again here I follow the rules we have learned, that coefficient of V A 0 will be 1 by 4 plus 1 by 2, no resistance here, plus 1 by 0, and the moment 1 by 0 comes in, we are at a loss because it is infinite. So, what to do with that? Similarly, coefficient of V C 0 will be infinite. Similarly, the sources, if you want to write at node A, it will be minus 2 by 2, that is fine, but here this 4 by 0. So, all these things complicate the matter. One way of doing this I am telling you, but you really do not do that. To avoid such a complication, okay, that point I will take later, but now let us see then what to do. Here, as I told you, see, there are 4 nodes. You can choose any of the nodes as your reference. Here comes the point. So, I have planned now, I will choose C as my reference prime. Between the nodes where an ideal voltage source is present, better choose one of them, either A and C as your reference, because there is a freedom there. I will not stick, because if I choose a reference node as O, I face this difficulty. So I will not choose, so I will choose my reference. This is, I will choose as a reference node. Then so this is useless, I mean no point in writing this one. So we will be doing it like this then. So choose C as your reference node, Then there are altogether 4 nodes. Then which node voltages are to be found out? I have to find out VAC, VBC and VOC. With respect to C, all the potentials then I will define. This I have chosen as a reference node. So, these voltages are to be found out now. So, reference node with respect to that point, all the other node voltages are now specified with respect to C. That double suffix, we are sure about it, what does it mean. Now, if you look at this 3 unknowns, we immediately say there is no resistance in this branch. VAC, potential of A with respect to C, start from C, try to reach A, and there is minus 4 volt. So, VAC is known, that is the most interesting point. VAC is known. So, out of these 3 unknowns, we note that VAC is known, and that is equal to minus 4 volt. Therefore, I will not attempt to write KCL at A, it is not necessary. So, not necessary to write KCL at node A. After all, there are now 2 unknowns VBC and VOC. So, we have to write down the KCL at node B and at node O, and I will generate those 2 equations from which I will be able to calculate VBC and VOC. Now, let us write that. So, not necessary to write KCL at node A. In fact, if you want to write it down, there will be difficulty, but nonetheless VAC is already known because there is a fixed battery here. Now, KCL at node B, let us write. Is not? Coefficient of VB0 will be sum of reciprocal of all the resistances, that is 1 by 6 plus 1 by 8 plus 1 by 2. 6, 8 and 2 are connected to B. So, this will be the coefficient of VB0. Coefficient of VC0 will be common resistance minus 1 by 8 into VC0, and coefficient of VA0 will be minus half, no, not VA0, I am, please forgive me, I mean I have made a mistake, because my reference node is this VBC I should write, potential of B with respect to C. Similarly, this one at nodes the coefficient of BC will be 1 by 6, 1 by 8, 1 by 2, and I am writing here. So, this term does not come. So, VBC and the coefficient of VOC minus, got the point, this minus 1 by 6 into VOC, because my unknowns are these VBC and VOC are the unknowns, VBC, VOC, and coefficient of A will be there, that is minus half minus half into VA0, VAC, is not, but VAC is minus 4 volt. So, this is you got the point. So, this into minus 4 volt, this will be the thing, and this is plus. On the right hand side, I will write down the sources, they must be dimensionally ampere. So, at node B this 2 volt is connected. So, it will be 2 by 2 and it will be plus, because plus is connected to B. Similarly, plus 5 by 6 plus 5 by 6, and of course, in this branch there is no source. So, this is one equation, and I will write down the KCL at node O, because O is not reference node, mind you, you can call it A, B, C, D, how does it matter. So, at node A, if you want to write down KCL, let us see what should I write. So, VOC, so coefficient of VOC will be sum of reciprocal of all the resistances connected to O, that is 1 by 6 plus 1 by 4, this one plus 1 by 10 VOC, coefficient of OC. Then coefficient of VAO will be minus 1 by 4 into VAC, because reference point is C now, VAC, this plus minus 1 by 4 into VAC, and then finally the contribution of VBC here. So, minus 1 by 6 into VBC, and this should be equal to, on the right hand side, sources at node O we are writing. So, it will be, as you can see, minus 5 by 6, because minus is connected to O, minus 10 by 10, minus is connected to O. And for this no source is connected. So, that is all, these are the two equations, of which VAC is known. So, this is equal to minus 4 volt I will write. So, two equations, two unknown, and after you solve, then you will be able to calculate all the branch currents. These branch currents I can calculate, because VAB minus 2 by 2 will be this branch current, this branch current. How to calculate this branch current? You then apply KCL between these 2 points to get this current. Got the idea? Therefore, remember that it may be situations like this. Therefore, like I told you that if number of equations to be solved by nodal method is n minus 1, for example, 4 minus 1 3, but if between two nodes an ideal voltage source is connected like this, then number of equations to be solved is one less, further one less, because one node of voltage will be known, provided you have chosen one of the two nodes across which a voltage, ideal voltage source is connected as your reference node. So, this example tells you now that it is not necessary. Two things it educates me. One thing is, in this one, any one of them I could choose as my reference node. I could choose B as my reference in general problem as well. Then your unknown will be VOB, VAB and VCB, like that. So, I think you have got the point. These are the points to be noted, that is, always it is not necessary all the below points you choose as a reference. Although people say it is visually attractive, okay. Otherwise, there is as such no restriction in that. In fact, that has been applied here to solve this problem. Got the point? Now, so number of equations to be solved here is only 2. So, if you are lucky between two nodes an ideal voltage source is connected, perhaps you have to solve one equation less. Therefore, given a network, look at the network carefully and see whether current sources are present in the outer loop and there are ideal voltage sources present between two nodes, whether you can exploit in terms of number of equations to be solved. If you can reduce that, you achieve something. Less time will be required to solve the network. Now, I will take another example. Now, suppose another way of handling this problem could be in this way, same problem. Why I am telling in various ways, so that you really understand fundamentally what you are doing, KVL, KCL, but now apply your intelligence to solve the network quickly. That intelligence level I am addressing to. For example, This could be also solved in this way. Let us see. Suppose I copy this one, this network, and I go to next page and I paste it. Okay, say the same network is here. Another way you could do it, you could solve this problem in this way. So, I will erase this C business. Another way altogether I am doing these things I have done. The advantage of that I told you, this is 10 ohm, is not, this is plus minus. I think all the components have been copied. Okay. Now, another way of handling this situation could be, okay, choose this as your reference node. Okay. And this is ABC, this is your this voltage. Now, another way of looking at it is that the potential of VAO, if I have chosen O as the reference, is nothing but VCO. Suppose you have got this potential with respect to O and then try to reach point A, and there you will find -4. Got the point? This is the thing. So, this potential is then not a another variable, but it depends on Vc 0 by a constant, add or subtract by a constant. So, Va 0 is this one. If that be the case, so this is one equation. Involving Va 0, Vb 0. Here what is the target? I have chosen this as my reference, Va 0, Vb 0 and Vc 0. These are my equations to be written. So, KCL is to be written to generate the equations, but one equation is gifted by the very definition of the problem, because Va 0 is nothing but Vc 0 -4 volt. So, one equation I have got. Then I have to write down two more equations, is not? So, two more equations how can I write? For example, at node A, KCL. I will now write KCL fundamentally, because that formula 1 by resistance in this branch will result into a infinitely large number. So, at node A, when I am writing it, you see it is a source. I will assume, but at the end when you solve the circuit, there will be a finite current flowing either this way or that way, that you could solve this problem in the earlier method. So, suppose I assume this current to be x ampere, in this direction it is flowing and it is related with this 4 volt source. Now, let us see KCL at A, what it will be. It will be the sum of all the resistances 1 by 4 plus 1 by 2, no doubt, 1 by 4 plus 1 by 2 will be this one, and this one I will treat it as a some current x is flowing out of it and that value is known. Like that I can do 1 by 0 I am not going to write. I will say, oh, there is a source and some x-ampere will eventually flow through it and that current is flowing out. So, and this I will show it. So far as these two currents are concerned, 1 by 4 plus 1 by 2 will be involved and this will be the coefficient of V A 0. Minus coefficient of V B 0 at node A will be minus half into V B 0, is not? Correct, minus 1 by half V B 0. So, at node A this current is V A 0 by this one. So, all the currents I have taken, this current and this current is only involved. B C 0, because that branch that current I have assumed to be x-ampere. So, this one I will write it as the sources connected at node A, that is minus 2 divided by this 2, and then another current is going away from node A. So, minus x, this way I will write then to avoid that problem. So, this is an unknown, mind you, unknown. I have assumed. Similarly, at KCL, at node B, KCL at node B, coefficient of V B 0 will be 1 by 6 plus 1 by 8 plus 1 by half. Coefficient of V A 0 will be minus half V A 0. Common resistance is 2, and the coefficient of V C 0 is minus 1 by 8 V C 0, and this will be equal to the sources, of which V A 0 is nothing but V C 0 minus 4, is not? V A 0 is nothing but V C 0 minus 4. I can, so another minus V C 0 by 8, and this will be equal to sources connected at node B. So, that is 2 volt is connected, 2 by 2, and 5 volt is connected plus 5 by 6, and there is no source here. So, at node A, B, I have written altogether how many unknowns are there. Once again, actually here 4 unknowns, V A 0, V B 0, V C 0 and x. So, I have written this is equation 1, this is equation 2, this is equation 3, is not 1, 2, 3, another equation I need. So, I will write KCL at node C, and that will be how much? It will be coefficient of V C 0 is 1 by 10 plus 1 by 8, and I will not going to write 1 by 0, because this I have assumed to be some current source feeding x ampere current, and this I will write on the right hand side. So this is coefficient of Vc0. Coefficient of Vv0 will be minus 1 by 8 into Vv0, and coefficient of Va0 will not come because it is a current source as if feeding that point x. So, this plus this must be equal to sources. Sources are what? 10 by 10 at C. This is nothing, and there is another current source coming in plus x. So, this is equation 4 and there are 4 unknowns. So, in summary what I am telling that to solve this network by nodal method, it is always better to choose O not as a reference, because then you are multiplying equation, number of equations becomes now 4 to be solved. In general, as I told you, in nodal method you have to solve n minus 1 equations. That is the usual case when there is no such ideal source voltage source present between two nodes. Then okay, if that be the case, then better choose one of those two nodes as your reference node, then you really get benefit. Number of equation is to be solved, as I have chosen here C as my reference, is only 2 equations are to be written and you have to solve that. And so that is one option, and the second option is you could choose O as your reference. Then what do I do with this branch? Because I cannot do some voltage by resistance here, although 4 volt is present. So, what you can do is this: you assume whatever current it will be flowing is x ampere, that I can always assume, okay, this part is x ampere. If that is x ampere and treat it as a, because the current in the circuit will be finite, nothing like that. So, finally, x will be a finite number, whatever that finite number will be after you solve the network, that variable you assume x. Then apply KCL at A. What will be the KCL at A? It will be, I mean, if you want to write from fundamental V A 0 by 4 this way, then plus V A 0 minus potential of this point, that is V A 0 plus 2 is not coefficient of at this current I am calculating. So, V A 0 sorry V A 0 minus the potential of this point, it is V B 0. Then to reach from this to this minus 2 volt divided by 2, this will be this current. So, this current and going away this current is plus x, that is equal to 0. So, coefficient of V A 0 at node A will be, you see, 1 by 4 plus 1 by half. From this really I have got this. Coefficient of V V 0 will be minus half, and on the right hand side what it will be? Plus 2 by 2 here, take it on the right hand side, minus 2 by 2, and this plus x comes here, you get minus x. So, these are the things. See, network solving problem, I feel it is sort of an art. It will vary which method you will choose from person to person, but always try to see that you have to adopt a method where you have to labor less. to get the solutions for the given network. So, you should be given a network, just do not jump that I will solve it by nodal method. Of course, there will be problems where you will be asked to solve by a particular method, then of course, you do not have any other choice. You have to solve by that method only if your examiner asks. But if you are given a free hand, apply your intelligence, whether should I solve it by mesh analysis or should I solve it by nodal analysis, by looking at the topology of the circuit, by looking at the various sources which are present in the circuit, and so on. I hope you understood this point. This will be the basis of your. So far what I have done, I have considered only constant value sources, sources are not time varying, and only resistance as your other elements present in the circuit, no energy storing elements. So, situations look like a bit simpler I have done, but we will now soon go into the circuits where there will be also energy storing elements will be present, and also the sources could be any function of time. That will start from our next class. Thank you.